this stuff. So same announcements that we've had all week. Today is Thursday, so obviously tomorrow's Friday. So yeah, get on it. If you're not mastered, you need to, do a hop, skip, and a jump and get yourself to mastery. So we left off last week talking about unit prices of juice, I believe, or something like that. Raisins, yeah, sorry, weird, right? Not juice, raisins. But here we're talking about converting money. Has anyone ever been to a country where they use euros? Like on vacation? Like maybe, like most European countries are going to use the euro. Somebody yesterday said they'd been to Italy. Kiki, where'd you travel to? France, and they use the euro there? That would make sense.
I don't know what Canada uses. I know they use toonies and loonies for their things.
No, you're thinking of Looney Tunes. No, I'm joking. I know. Canada uses like a funny named currency. So guys, please in your notes write down E equals 17 times D. And then we actually want to write the words that go with those values. So what that means is that the amount of euros, I'm still deciding how to use my camera. I'll let me back up here. Alright. I need more tape. As my camera's held on here with tape. No, I have plenty. I just need to put more on this. Thank you, though. I will see you guys next week, and I'm very excited for that. So, guys, E equals 17 over 20 times D actually means the amount of euros that you could get when you exchange a certain amount of dollars is 17 times 20, or 17/20 times the amount of dollars you give up. So you would either like go to a bank or go to an exchange station and you would give them a certain amount of dollars. So what I want you guys to go into breakout rooms and talk about really quickly is, what do you think is worth more? Is a euro worth more or is a dollar worth more? And we're going to look at both exchange rates here. So what we're talking about is when I give up $1, how many euros do I get? Or how much of a euro do I get? And when I give up €1, when I'm coming back home and I give up my euros to turn them back into dollars, what would I get there? So we're going to talk about both of these exchange rates. Take a moment, pop into your breakout rooms, just chat about this for a second, see what you guys think. And if what you say is like, yeah, this is confusing, see if we can remember what we said on Tuesday about the two different unit rates and how they compare to each other. So I'm going to open up like probably 6 breakout rooms. Let's do that. Let's try that. I'm going to check chat while you guys are gone, so if you sent me something in chat, I'm going to check that now. Brady, you're here now. Brady, what's up, my man? You're good. So they're in breakout rooms right now, but we're going to come back in just a second, so I'm probably just going to leave you in here for right now. To avoid confusion, because I'm going to pull them back, like, now. So you're good. I just sent attendance, so I did not... Oh, there's Caroline. Dang. Now I got to email the office real fast. All right, so guys, what we should have written down on our paper, let me check if that, nope, 2 more seconds. We'll make sure everyone gets back here. what we should have written down on our paper is E equals 17 times D. And if we plug in a 1 for dollars, like if I just give up $1, remember, this is the symbol for American dollars. That is not the symbol for anybody else's currency. So when we plug in $1, then we get back 17/20 euros. So like 0.85. So what does that mean? What would you like? Is a dollar stronger or is a euro stronger? Charlie, and then for the rest of the class, I'm probably going to have to call on other people.
Okay. A dollar is stronger because what you're doing is you're dividing 17 over 20 to get you to 85 cents, which is less than the singular US dollar.
It's equivalent, though. So remember, this is not 85 cents. That's 85 hundredths of a euro. So sorry, did you say the euro stronger or the dollar stronger?
Oh god, this is so confusing.
I know. So let's look at it like this. This is super confusing. What about 1 euro? Right? So part B, we're asking what about for 1 euro? So remember that when we talk about the 2 unit rates, the 2 unit rates will be reciprocals of each other. So guys, I don't mind if you write down all of this work or not, but this is how we get to the reciprocal, is if we do the inverse operation, or really when we inverse operation with fractions, we can just multiply by the reciprocal. Remember, this will become a giant 1. So if we wanted to plug in 1 euro, which by the way, the symbol for euro looks like that. It's like a really funky looking E. In a way, it's kind of like a C with 2 lines in it. But so 1 euro is what would currency symbol go in front of that. 1 euro is equal to some amount of dollars, and we know the exchange rate, the sum amount. We figure this out, and the D, the amount of dollars, this is not $1, this is the amount of dollars, will equal 20 over 17, which is actually about $1.18. So it would take $1.18 to buy 1 euro. It would take us $1.18 to buy 1 single euro. That means the dollar is weak. So I'm moving my camera since I'm able to move my camera today, and I realize I should probably just have it over here. Guys, that tells us that we need more dollars than what we get back in euros. This is equal to 1 euro because that's the math we just solved. So we could actually make another equation instead of the E equals equation up here. We could make a D equals 20/17 times E. It's the other unit rate. It's the reciprocal. This is probably one of the most difficult problems we're going to do today. I had a couple of you ask me about this in your homework, and that's why I wanted to make sure we go over it. This is a weird problem, but what you need to remember is they're reciprocals of each other. If you look at this in decimals, it's really complicated. It doesn't look like reciprocals. If you look at it in fractions, we can tell that they are reciprocals. So guys, we're going to move on because this problem is pretty tough. I want to move on to some easier things, like move back to some easier things. So feel free to come to extensions if that does not make sense to you. I want you guys to go back into your breakout rooms and chat about what does the 4.5 mean in this situation. And the reminder that I want to make to you is be careful that you pay attention to the label on the axis. Okay, so if you don't have Schoology open, you might need to open Schoology or quickly take like a screenshot of this or whatever. But I'm going to send you back to your breakout rooms. What does the 4.5 mean in this situation? Yo. Nope, you got to fix it. It is your job to encourage your breakout room peeps to talk. Try it again. Here, we'll add somebody else to your breakout room too, because we had a couple new people show up. Do you guys have Schoology open so you can see the graph we're talking about? I remember the number is 4.5, like 4.5. So in this graph, what does that mean? What does the point 1, 4.5 mean? What does 4.5 mean in that graph? Here, we're going to close the breakout rooms because this is not working right now. Guys, if you head to a breakout room and you have no idea what you're going to do in the breakout room, and neither does anybody else, it's pretty tough to make the breakout room worth your while. Like, so if you're going to come to class and you're going to do stuff, it might as well be worth your time. Don't go to the breakout room if you don't know what's going on. What we're discussing here is what does the 4.5 in this graph mean, and more specifically, what does the point 1, 4.5 mean? So let's, everyone in your notes real quick, try to draw a version of this graph. It doesn't have to be perfect. We know we're not all artists. We've got some artists in our class. I'm trying to cover some stuff up. But label everything they labeled. Label everything they labeled. Let me see if I can cover this up without knocking stuff off. When we talk about points, by the way, Kiki, yes, absolutely. I could not send you a message because we weren't in the same room at that time. When we talk about a coordinate, a point, we often just call it a point, but guys, the fancy name for this is coordinate. It's x, y. The x value relates to the horizontal axis. So in this case, we drop straight down from our point to get our x value of 1. I'm kind of going to walk through this slowly to make sure you have plenty of time to put this in your notes. I should see the top of your head looking up ever so often as you take notes. Right? The y, we go across to the the vertical axis. We have to go sideways to get over there, but then we notice that that point right here would be 4.5. Preach, you got your hand up. What's up, man?
Just going to see the answer to it.
All right, what's 4.5 mean in this situation? What is our answer?
It's like, the answer is like he's going to get 4 or 5 eggs each day because 4.5 is in between 5 and 4.
Yeah, so that means about 4.5 eggs each day. Guys, please make sure you write this on your paper. Here's the trap door. When we say it, we almost always say the y first, like when we say it with words, like when we say a sentence. But when you say the point, the x comes first. So when we say it with words, 4.5 eggs for each day. Sorry, I'm trying to zoom in. That says the y value first. But when we say it as a point, it's the x value first. 1 day, 4.5 eggs. Does that make sense now? Because every room that I popped into, you guys were kind of like, we're confused. Does this make more sense now? If I ask you another question like this. So here's the trick. You want to go to the axis that corresponds with that value and see what the label is. So here, y, this is the y value because it's the second point. Go over to the y-axis. It says eggs, so we know that it's 4.5 eggs. Now, you can't actually get half an egg, so that means he gets either 4 or 5 every day. It probably goes back and forth, right? Some days there's 4 eggs, some days there's 5 eggs. If you have a question on that, stick around here. Otherwise, go to your breakout room and talk about what the 16 means in this situation. I will recreate the rooms this time. What does the 16 mean in this situation? If you don't have Schoology open, make sure you look at it before you leave and decide, what does the 16 relate to? Does it relate to hours? Does it relate to scarves? What do you think?
I think it relates to the hours. I think it means that he's
This is the point where you conversate with each other. Or did you already decide?
I want to see the graph again because.
Then open up Schoology.
Oh, okay.
That's now like the expectation this week that I've created is open Schoology. But you're lucky that I like you because there's the graph again really fast if you just want to see it right here. But I said at the beginning of class, open Schoology so you can follow along. Now that said, and with the graph shown, I'm going to pull us all back. So you guys have 1 more minute to talk about it.
You would say yes to just the whole idea.
Man, I don't know. I think you guys think I'm evil and like assign homework every single day or something. Well, thank you. I don't know if that's true, but this is also the weirdest year you've ever had.
I don't like math.
Well, neither do I, really. I've just made a job out of it. That's a joke. I'm like in love with math. Anyone want to volunteer? Actually, let's put it in the chat. What does the 16 mean? Leah, you're giving me a weird look, but I'm serious. Math is beautiful. I love it. I apply it like every single day. Put it in the chat. Chat it to me privately, please. Is it hours or is it scarves that the 16 relates to? Is it hours or is it scarves? C is not an answer, even though it's the most... Well, okay, if you look at the multiple choice, fine. You're right. I forget that I left the multiple choice. I normally don't leave the multiple choice here. I just leave this question. I should have deleted this part. I don't know why I put it in there. I guess I wanted to be nice to you guys. That's uncommon. It is hours, right? As pretty much every answer coming into the chat tells me, that means it takes 16 hours for 1 scarf. So if we write this out in XY form, our X is 1 and our Y is 16. We look at the labels on the axes and we see that the X-axis is scarves, the Y-axis is hours. So we would say it as 16 hours for every 1 scarf. Now, guys, if that means that 16 is our unit rate, what's the reciprocal of 16? Samaj, are you with me? I can't tell if you're looking up to think or if you're watching TV. What's the reciprocal of 16? Well, guys, what's 16 actually over top of?
1 over 16 is reciprocal.
And if we take the reciprocal unit rate, all we have to do is flip around the label that we had. So if I take the reciprocal of my unit rate, I literally just flip around the order of the words. So, I forget who this is. Ted. Ted can knit 1/16 of a scarf every hour. By the way, Kiki's got a pretty fly hat on today. I'm digging that. It's very, it's, Bruno Mars. Is that who I'm thinking of? That it looks very like Bruno Mars-like? I'm trying to, I could be wrong. I don't know who people are. Does anybody...
It looks like one of the fedoras, Bruno Mars.
Yeah, fedora.
Old videos
That's
from like the early 2000s.
old. Ow. Ooh, that just hurt. That stung just a little bit.
Why did you put that image into my head?
What, Bruno Mars?
No, Bruno Mars in like the early 2000s.
This one is tougher. I will warn you. This one's tougher. It's asking for both unit rates, so be careful where one goes versus the other. But this is asking for both unit rates. Guys, if you don't have Schoology open so you can look at our slides, please open it. Because I'm going to put you back in your breaker room so you can talk about this and decide what unit rate goes where. Because they're going to be reciprocals of each other, but what are the unit rates and where do they go? I'm only going to give you like a minute or two in there, so talk about it quickly. And guys, when it says you can come back, wait it out. If you're still talking, keep talking. It'll bring you back at the end of the minute. It will bring you back on its own. Well, I'm missing this page. See, there's still 20 awkward seconds that we all have to wait here until the rest of everyone comes back. So I think maybe we should make a new policy where we just wait out the minute. Like, even if you're in the breakout rooms, it's less awkward if you just chat with each other. Unless it's more awkward. I don't know. Maybe I'm wrong. Maybe you guys don't want to, like, just hang out and talk with each other. Alright. So, I promise I am going to make our random cards when you guys are back here. I just feel like on Zoom, this is super awkward for me to like just call on people. Can I get a volunteer to talk to me about how many cups of popcorn Harlan uses per 1 cup of cereal? Charlie and Harish, I'm not calling on you. I'm looking for other people. Clark! How many cups of popcorn per cup of cereal?
So popcorn per cup of cereal is 2 cups of popcorn per cup of cereal.
Absolutely. So if we want to write that as an equation, we would write popcorn is equal to 2 times the amount of cereal. Now guys, please ignore the red line and ignore the blue line, but take a moment in your graph paper to go ahead and draw this graph and label this axis with popcorn, label this axis with cereal. I'm sorry that this has writing all over it, but I thought it was actually a pretty nice graph. So then, the reason that I want you to show this whole graph is the y-axis. I should not use a color that's also on the graph. The y-axis, right, is our popcorn label. So we can actually replace popcorn with the variable y. Cereal is our x-labeled variable. So we can replace cereal with x. So our popcorn will be 2 times the cereal. And guys, this is where a lot of you are struggling on the proportional relationship graphs, is recognizing that this point right here, 1, 2, means 1 cup of cereal 2 cups of popcorn because it's X then Y. So this point, we go to the X, we go to the Y, it's X then Y. Yeah, guys, you can always go use the restroom. I'm never going to say no. Sorry, I don't always look at chat immediately. So please, if I don't see what you put in chat, just realize that's a me thing. You can always go to the bathroom. Well, no, that's not a statement you should trust. I will always allow you to go to the bathroom. You can't always go to the bathroom. Sometimes it is not appropriate. Okay, well, Miss Allie is different than me.
I was about to say, that's just Miss Allie,
Yeah.
man.
Miss Allie also doesn't record her classes. So if you miss something from my class, you know.
Miss Allie's
Guys,
the only teacher that tells you to ask.
I'm not going to say I'm better, but I've had 9 years of practice at this. I'm a bit more laid back. I've gotten used to what's like okay, and it's weird to have kids leave your class. It's really weird. So I'm not picking on Miss Allie. That's the weirdest thing to get used to at Phoenix, when kids just get up and leave. So I get why she would say to ask, but I don't care. If you have to pee, you have to pee. Just if you come back and you're confused, ask a question. So guys, then what I want us to look at here are some other lines that would not be the same situation. So let's say that we have a point out here at the values of 5, 1. Right? If I drop down my x value and look at what it is, it would be at 5. And if I go across to my y value, it would be at 1. But what that would actually mean is my y equals my equation for that line. The equation that we write for proportional relationships, I don't know where my black pen went. Ow. Alright, well, we're going to write in purple. This is always going to be y equals y over x times x. So guys, I would put this in your notes if I was you. When we set it as y equals, when we get the y by itself, it's y over x times x. So when you have a point, we put the point, y over x, my y value is 1, my x value is 5, and this is now the equation of that blue line. Let's take that point and flip it around though. If we have the point at 1, 5, so this point right here is at 1, 5, that would be y equals 5x, and you'll notice that as this number gets bigger, the steepness of the line goes up. So this would be somebody who really, really, really likes popcorn. Right? Notice how I made this red line point to popcorn. They're using 5 cups of popcorn for every 1 cup of cereal. This person loves popcorn. This person loves cereal. The blue person. The black line right here, they are following the recipe. So when you are doing your homework and you're trying to match up which graph matches the situation, you have to compare your constants of proportionalities, which, guys, remember, your constant of proportionality is y over x. Your constant of proportionality is y over x. So I want you to head into your breakout rooms and talk about this one. If Satoko has 30 tokens to take to the arcade, which game, if you're going to play the same game the whole time, which game can Satoko play more times for 30 tokens? I am sorry, I chopped off the C up here, and I moved this for last class, so I can move it back if you guys want. But it just said, like, Satoko's 3 favorite games for various number of times, so we don't really need to move that. You don't really need to see the multiple choice either. Order, bring the front. So sorry, I chopped off the C for cost. But hop in your breakout rooms, talk about which game could you play the most for 30 tokens. What's up? Yeah, I spilled coffee on the way in here.
Yeah, okay. I was
Yeah,
curious.
so the only thing I had to clean it up with was these like Lysol wipes. So
You're good. I just saw like a Slimer trail and I was curious as to what it was. Now I know.
because of that, now I brought it down.
Oh, okay.
And I was like, I don't even have paper towels here. I don't have tissues. I was like, I gotta bring everything.
Awesome.
So my bad, dude. You guys need anything? What's up? I saw the request. Ah, yeah, you guys have to screen share in your breakout room if you want to. Otherwise, you have to have Schoology open. Sonny, what are you doing, man? What's up? Yeah, what? What are you doing? What do you mean you checked Schoology? You're laughing at something. Don't lie to me, man. What are you doing? Am I recording when you guys go to breakout rooms? Remember that we go to the Math 7 page. We go to Remote Round 3. And the slides are right here. Although sometimes Schoology can't load certain things. We are looking at this problem right here. So if that can't load on your computer, it looks like it might be a your computer thing. You might need to run an update or something like that. But we were looking at this slide right here with the claw, DDR, and KOF. I don't know what the game KOF would be. I'm going to say it's kangaroos on fighter jets. Claw machine is claw machine, and DDR, right, Dance Dance Revolution. So which game? I want you to put it in the chat. Which game can we play the most amount of times for 30 tokens? Can we play the claw machine the most? Can we play DDR the most? Or kangaroos on fighter jets? I'm glad that I saw a couple of you guys laugh at me saying kangaroos on fighter jets. I don't know what KOF...
And KOF, and the game KOF actually stands for the King of Fighters.
Okay, I was wondering what KOF meant, because it looked like this problem was using actual games. Yeah, everyone in the chat that also texted it to everyone. Remember, try to make your chat private to me. It's okay if you send it to everyone, though. It's KOF, right? Because if we look at the cost per time that you play it, it's the lowest, right? The slope is the lowest. So we want to make sure you don't have to put that graph in your paper, but I want you to have that the slope of a line is a new word that we're going to start talking about. Slope is y per x. So it's also known as our rate, right? The rate of how much something costs, or the rate of how fast you're traveling, or the rate of, this is kind of gross, but hot dogs per minute. So we want to compare these hot dog eaters and say who's the fastest, who's the slowest. So I want you in the chat, switch it to private if you can, please. Tell me first who's the fastest hot dog eater here and who's the slowest. And then, bonus question. After 6 minutes, approximately what's the difference between them in number of hot dogs? After 6 minutes. Now, let's go 7. Yeah, 7 works. After 7 minutes, what's the difference in how many hot dogs they ate? Take a moment. Thank you. Looks like everyone has been switching their chat to private. If we want to figure out the difference in the amount of hot dogs they ate. Oh, I've only got one person who sent me the answer for difference in amount of hot dogs. That's a really good guess, the person who sent me that answer. So guys, I know that there are some of you, and we're almost out of class time. There are some of you whose faces I haven't seen this whole time, and I decided that I was just going to stop fighting with that whole, like, trying to get people to turn their cameras on and stuff. If you have worked the system, and, like, you're watching Netflix at the same time as right now or something, and you're behind on math, like, that's gonna matter when we get back to school, but it will be easier to take care of when we get back to school. So I decided, like, I wasn't gonna stress about that stuff anymore. So whether or not you're turning your camera on or not right now, I don't really even care about that. What I care about is if you've been focused during class or not. If you haven't been focused during class, it might be a little uncomfortable as we get back here and we start to take tests on paper and like homework on paper and everything on paper. So, please try to make sure that if you're behind on stuff, you need to do some catching up. I've got videos in Schoology. I've got videos in YouTube. I've got a bunch of stuff going over this. I've got all sorts of guesses. 8, 13, 9 or 10, possibly. So the difference in hot dogs, we're going to find out here, right? Everybody unmute, shout it out. Who's the fastest? L, right? L is the fastest because they have the highest rate or slope, right? So the higher the line is, the steeper the line is, the higher the rate is or the slope. So in this situation, we're talking about hot dogs per minute. Contestant L, I don't know, what would we guess this is? Just unmute, and what do you think it is? 30?
35?
A little bit more than that, probably. 37, 38, something like that. 37, 38. How many did contestant K eat?
Like 25.
Like 25, 26. So yeah, there's like potentially like a dozen hot dogs. Guys, I couldn't eat a dozen hot dogs in 6 minutes if somebody tried to pay me, let alone a dozen more than somebody else. Challenge. I think you'd get to like hot dog number 4 and realize what you had, what mistake you had made. Alright, this is...
The key to it is to not really pay attention to what you're eating and forget that you're shoving 12 hot dogs in your mouth in 6 minutes.
Gross. Just like peanut butter covered ramen.
Exactly.
Guys, last thing we're going to do today, because I want to make sure that you're ready for your homework. So I know I got people trying to catch up over the weekend. Please go ahead and put these tables in your notes. I'm going to stop talking for a second while hopefully you can just write these tables real fast. You could just put like sugar lemonade, hours, earnings. Like you don't have to put all of the details. And actually, I'm going to go ahead and show all of my notes because we're running out of time like crazy bad. I'm sorry because I'm taking away some of like the learning opportunity of you guys like having a little bit of time to struggle and figure stuff out. But I realize we're out of time in 4 minutes, right? I always try to cut to give you a 10-minute break. So I realize I'm out of time in 4 minutes. When we go to check proportionality, I'm going to move this for a second. To check proportionality, we have to do 2 things. This is super, super important, so that's like why I moved down here. The 2 things we need to check are going from x to y, which is the constant of proportionality, right? Inside of our table, going from x to y, that was our constant of proportionality. So up here, we check it, this is times 3, times 3, times 3. Okay, in the table means going across from x to y. The other thing we're going to check is going from a little, I meant this to be x to x, y to y. They let me get away with writing this wrong the other day. This should be little x to big X, little x to big X, and little y to big Y. I can't, this. Little x to big X, and little y to big Y. What I mean by that is check little x to bigger X, little x to bigger X. Are these the same on top and bottom? So, from my first spots to my last spots is times 9. But down here, our second table doesn't work. I'm going to pull this up so we can see a little bit more. So this is the last thing we're doing today, because this is, I think, the last stuff that will really matter to your homework completion. So what we're looking for is both across the table in it and on the outside of the table. So our second one here is broken all over the place, guys. Let's look at our second one. I'm going to zoom into the second one here real quick for a second. If I check it in the table, from 1 to 20 is times 20. From 2 to 30 is times 15. From 3 to 40 is like times 13-ish. So these purple arrows aren't all the same. That's bad. That's really bad. This is already broken. We don't need to keep going. But if I want to keep going and check the other thing, on the outside of the table, I go from a little x to a bigger X, 1 to 3. That's times 3. On the bottom, going from my little y to my bigger Y, that's times 2. That's not the same. That doesn't work. Any questions on how we can identify that this is not proportional? The top table with sugar and lemonade is proportional. All of these arrows are identical. On the outside of the table, they just have to be identical with each other. So notice, this is not times 3. The big arrows are times 9, but that's okay. Down here in the hours and the earnings. So think about it like this. So Charlie, I hire you to come rake leaves at my house. You rake leaves for an hour and I hand you a $20 bill. I'm like, I got 3 hours of raking in the backyard to do. You want to rake? And she's like, yeah, sure. And then I hand you $40. That's not fair, right? If you were getting paid $20 an hour, what should this be? What should this be? 60. This is not fair. I ripped you off.
How dare you, Mr.
How
Hudson?
dare I? So this is not fair. This is a crappy place to work. You get paid less as you work for longer.
Yeah.
I'm only going to work 1 hour at a time.
I'm rake leaves for you again.
Well, you never.
I would not recommend.
I have never paid anyone to rake leaves for me yet, and I am going to cling on to that. All right, so one last example. If you want to see another non-proportional relationship, you don't have to write this down. But if I went, this is another homework problem that you're going to see. If we went from 3 to 12, 7 to 35, and 10 to 60, that also is not proportional, because this would be times 4, this would be times 5, this would be times 6. That's not allowed to happen. You can't change this relationship. All right, I'm done. I promise I'm done. That's it. Unless you have questions, have a great day. Take a break before you get to your next class. Sorry I went a little longer today. Have a great day, guys. Bye-bye.
Thank you.
Thank you.